Let's take a look at section 4.3. In this section, we're going to look at some different numeration systems in our own decimal system, and we're going to look at some different base systems. It is going to seem a little different and challenging, but hopefully you'll get the hang of it.
So this section is all about different types of number systems. So we're going to start out in the number system that we all know. And this particular number system that we know is known as base 10. So anytime you see base 10, you rejoice because that is simply counting like you have always counted since you were 2 years old. So whenever it says count the number of shapes in the indicated base 10, you just count these 1, 2, 3, 4, 5, 6, 7, 8, and the answer is 8. So that is as easy as it gets, okay? But now we're going to change this number system, okay? So now instead of base 10, we are in base 3. And basically what that means is instead of grouping things in groups of 10, we will group things in groups of 3. So we still have 8 objects up here. And I'm going to do this in a way of showing you by division. And this is probably the most difficult part of this section. So I hate that I'm doing this right off the bat, but I pretty much have to do this. So, if you may have to replay this part a couple of times, but this really is the most difficult part of this section, okay? So the first thing that you want to do is you want to start off with your base 10 number. So in that case, our base 10 number is 8 because we have 8 shapes. All right, then the second thing that we're going to do is we're going to divide this number by our new base number, which our new base number is 3 because that's the new base that we want to put these in. So we are going to divide this number, we're going to divide 8 by 3. When we do that, we get 2. Now, if you remember division, 3 will go into 8 2 times. 2 times 3 is 6. And if you remember, you would do 8 minus 6, and you would get a remainder, and that remainder is very important. So the remainder is what goes off to the side. So in this case, you get a remainder of 2. And so that's from, we said 2 times 3 is 6, and 8 minus 6 is 2. Okay, so that's where the remainder goes, is off to the side. Now, the next step is that we're going to repeat until you get right here. We want this number right here to be a 0. So until we get 0, we're basically going to repeat steps 2 and 3. All right, so again, we're going to divide by 3. Now, 2 divided by 3, you can't divide 2 divided by 3. 3 won't go into it, so that is going to be 0. Now, whenever, that's the magic number, so we're almost finished. That's great. 0 times 3 is 0, but you have 2 minus 0 gives you a remainder of 2. Okay, now you are done because you got a 0 here. But what is your answer? Well, your answer is actually this remainder. So, and it is written going down. Okay, so going down is how it's going to be written. So base 3, 8 in base 3 is actually 22. All right, so I know that's kind of confusing, so we're going to do another example. All right, so let's take a look at another one. So we're going to take the same number 8. All right, but this time we're going to do it in base 5. All right, so we're going to do 8 and we're going to do base 5. So let's start out with 8. And we are going to divide that by our new base number, which is 5. Now, 5 will divide into this 8. Okay, 5 will divide into 8. How many times? It will divide into 8. How many times? One time. So then 1 times 5 is 5, and so my remainder is going to be 3. All right, so I put my remainder over there. Now, am I done? When are you done? You are done when this is what number? This is a 0. So we are not done. We have to divide again. So we have to repeat until we get a 0. So we're going to divide again. Now you get a 0. So we have to do 0 times 5, which is 0. 1 minus 0 gives me a remainder of 1. And then that is going to be, I'm done now because I got a 0. So the answer is my remainder. Remember, I read this going down. So in the number 8, base 10 is the same thing as 13 in base 5. Okay, so maybe it's clicking a little bit more. How about we do one more example? Okay, base 2. So this time we're going to be dividing quite a bit because we have base 2. So I'm going to start with my base 10 number, which is 8, and I'm going to divide by 2. I get 4. 4 times 2 is 8, so I have a remainder of 0. Now, am I done? No. So I'm going to divide by 2 again. This 2 will go into 4 2 times, and it divides evenly. So I get a remainder of 0 again. And I'm still not done because this is not a 0. So I have to divide again. So 2 divided by 2 is 1. And it divides evenly. So I get a remainder of 0. And I'm still not done because this is not a 0. So you divide again. Whenever we divide again, we get a remainder. Finally we get the 0 up here. Okay, so when we get a 0 up here, 0 times 2 is 0. 1 minus 0 gives me a remainder of 1. Okay, remember then that we are going to read this going down. So base 2, what is my answer going to be? So the number 8 in base 10 means in base 2, my answer is going to be 1,000. Okay, I know that's quite bizarre, but you will find out that, and actually as you do research into different historical in different history and different historical societies, you will find that they worked in different number systems in different bases. And so this is kind of an interesting thing. So actually this is a little bit of math. So for those of you who have been wondering when we were actually going to do a little bit of math, here we are. We have finally done a little bit of math as you know it. All right. The next set of problems are going to ask for you to write the number in expanded notation. So in order to do that, I decided we would start with an example in base 10. So we're going to look at this 1048.31 in base 10, and we're going to write it in expanded notation. The first thing we're going to have to do is we're going to have to label all of our place values. Now, the very most important thing that you have to do is label the first number correctly. And that is going to be to start with this first number to the left has to be labeled with a 0. Okay, and you'll see why in just a minute. But that's going to be place value of a 0. Then we're going to continue going to the left, and we're going to go, and that's going to be 1, 2, 3. If there were other numbers, it would be 4, 5, and 6, and so on. Then we're going to go over to the right side over here, we're going to go over here and we're going to label these, and they are going to be negative numbers. And so that's going to be -1 and -2. If we had more numbers over here, they would be -3, -4, and so on. Okay, so now we're going to look at this first number right here, okay? And we have that expanded notation, and it's 1 times 10 to the third. Now, the 1 comes from right here. That's the actual number. 10 comes from your base, and then 3 comes from the place value. So that's where all of these numbers come from. We're going to add each place value together each time. Okay, so the next set would be 0 times 10 to the second power. And again, 0 times 10, base 10, to the second power, which is the second place value. Then we have 4. So 4 times 10, base 10, to the first power. Then we have 8 times base 10 to the 0 power. Now, why is this important? Well, anything to the 0 power is equal to 1. And this is the ones place. So that's the ones digit. So that's why we have to have that as our place value. We have to have that 0 in there. So that is the number one mistake. And most of the time, if anybody gets this wrong, that's where you're going to get this wrong, is by starting this place value written with 1 instead of 0. So just be careful with that. Now we have to go ahead and continue this to add in anything to the right of the decimal. So we're going to put 3 times 10 to the -1, and then 1 times 10 to the -2. Now this is actually your answer. That is the number written in expanded notation. So, as you know, as ugly as that is, and as long as that is your answer. The only thing that might be different here is that you don't necessarily need this part here because it's 0. So if you have a 0 in your number, that number, you don't even have to have that in your expanded notation. It's not necessary. So, so that's not necessary to have into your expanded notation, but otherwise all of the rest of these numbers would be in your expanded notation. But just to prove how this actually works, you can multiply all this out. So like this first example, 10 to the third would be 10 times 10 times 10, which would be 1,000. 1,000 times 1 is 1,000. The second is 0. 4 times 10 to the first is 10. 10 times 4 is 40. Remember, 10 to the 0 is what number? I hope you said 1. And then 1 times 8 is 8. 10 to the -1 is 0.1. And then 0.1 times 3 is 0.3. And then this would be 0.01. Now, if you take a calculator and add all of these numbers together, you will get 1048.31, which this number is exactly what we started with. So I just wanted to prove to you that that's how that expanded notation works. So let's take a look at another example of how this works in a different base. Okay, so now we have a pretty ugly number here in base 4, and we want to write this number in expanded notation. So the first thing I want to note here is there are several zeros here. I actually like seeing zeros because that means that I don't have to deal with those. And so in a few minutes here, those are going to be my friends. Now, remember the first thing that we want to do is we want to label all of our place values. So let's go ahead and do that. Remember, we started our decimal. And so if you notice here, I put 0, 1, 2, 3, 4, 5, and then -1, -2, -3, -4. So that's going to keep us all in check. So we know exactly which place values we're looking at, okay? Now the next thing I'm going to do is I'm going to take a pencil and I am going to mark through these zeros because I'm not going to need those. They're not going to mean anything, so I'm just going to mark through those. Okay, so that's less work for me to have to deal with. So now all I have to do is concentrate on these place values that are left. All right, so the first place value I'm going to look at is going to be this 1 right here, and it's going to be 1 and times 4 to the 5th power, right? So 1 times 4 to the 5th power. Now you tell me what comes next. So based on this right here, so what would this one, how would you write that? Okay, so you should have 2 times 4 to the 4th power. Then next will come 3 times 4 to the 3rd power. Remember that this second power place value doesn't matter because it's going to be 0. So we can actually skip that and go right here to this one. And so that would be 1 times 4 to the 1st power. I can skip the next one, and I can actually skip the next one. And then I can go to this one right here, 1 and the -2 place value. So that's 1 times 4 to the -2 power. And there's one more, and it's this last one right here, 1 times 4 to the -4th. And that's your answer. So when it just asks for you to write the number in expanded notation, that's exactly what they're looking for. Okay, so don't make it any harder than it has to be. All right. Okay, the next set of examples are asking you to change the number to base 10. Now, the easiest way to change these numbers, so you have a number here, 5722, and it's in base 8. To change it to base 10, the easiest way is to write it in expanded notation and then multiply it out and then figure out what the number is. So let's do that. We're going to write it in expanded notation. So in order to do that, the first thing we're going to do is do our place values. So 0, 1, 2, and 3. Then we are going to write this in expanded notation. 5 times 8 to the 3rd plus 7 times 8 squared plus 2 times 8 to the 1st plus 2 times 8 to the 0. Okay, now is when you want to grab your calculator and you want to actually multiply this out and see what these numbers are. So for example here, 8 to the 3rd power is 8 times 8 times 8, which when you do that, you get 512. And then you have to multiply 512 times 5. And when you do that, you get 2,560. Okay, then you're going to do 8 squared, which is 8 times 8, which is 64. And then 64 times 7 will give you 448. Then this is just 2 times 8, which is 16. And then remember, 8 to the 0 power is what number? It is 1. And 2 times 1 is 2. Okay, so don't let that trip you up because that's something else that a lot of people do. They want to say that this is 2 times 8, but it's not. It's 2 times 1. So be real careful with that. So that's 2. Now take your calculator, add all of these numbers up. So add those 4 numbers up. Okay. So when you add all 4 of those numbers up, you get 3,026. and that is the number in base 10. So that would be your final answer. Okay. So how about we do another example? I'm sure you're just dying to do another example. So that'll make you feel better. I'm sure it will. All right, so let's look at one more. How about we do 2110 in base 3, and let's change that to base 10. So this is usually where I would say, why don't you pause it and you work it out. So pause the video, you work this out, and then you can come back through in just a second and play it through and check your work. Okay, so hopefully you have worked through this, and so you're just checking your answer. Well, you are going to label your place values 0, 1, 2, and 3. And then remember this is in base 3. 2 times 3 to the third, 1 times 3 squared, 1 times 3 to the first. This last one, remember, it doesn't really matter. I just wrote it there, but it's 0, so we didn't even really have to write it. Okay, 3 to the third is 3 times 3 times 3, which is 27. 27 times 2 is 54. Then the second one there in blue is 9. Then you have 3 and you have a 0. You add all of that up, you should have gotten 66 as your answer. So if you got 66, big pat on the back. If you didn't get 66, try to figure out where your mistake was. So hopefully you'll be able to see where your mistake was. All right, you've got a few of those to work on in your homework. There's some more homework problems that are asking you to change from base 10 back to other bases. And we covered those at the beginning of the slide where we did the division. So you'll need to go back and look at those. All right, the last problem I want to look at is a problem-solving problem. And there's several of these on your homework, but I just thought I would use this example and go over this with you because they all work similar. This one was just intriguing to me because I had several students that asked me about this one. And so it says add 2 gross, 6 dozen, 4 units to 1 gross, 6 dozen, 13 units. Okay, now the first thing you have to do is understand gross, dozen, and units. And if you don't know what gross, dozen, and units are, and you can't find it in your book, well, then you can't just say, I don't understand. What do you do when you can't figure anything else out? Well, you do what everybody does. You Google it. Okay, so just Google gross, dozen, and units, and you will find very quickly that 12 units equal 1 dozen and 12 dozen equal 1 gross. So those two equalities are going to be very important in this, and you have to know that. So in order to solve this problem. All right. So what I'm going to do is I'm going to take the 2 gross, 6 dozen, 4 units. 2 gross, 6 dozen, 4 units. And then I'm going to add the second set was 1 gross, 6 dozen, 13 units. Now I'm going to set them up vertically and I'm going to add them together. And I'm just going to go ahead and add them. So 2 and 1, it gives me 3 gross. Then I have 12 dozen, I have 17 units. Okay, now I'm going to actually start with my units. So you always want to start with your smallest and work towards the largest. So if you're working with money, you want to start with your pennies, work towards your dollars, okay? So it doesn't matter, always start with your smallest, work towards your largest. All right, so 17 units. Remember from up here, 12 units equals 1 dozen. So if you have more than 12, you can take those 12 out and it equals 1 dozen. So I have more than 12. So I can take 12 of these out. And that's what I'm going to do. I'm going to take out 12 and that makes 1 dozen. So now I'm going to add that dozen over here. So that gives me 13 dozen. And then over here, when I subtracted the 12 out, that left me with 5 units. Okay, so I took out 12 units, which was 1 dozen. Same thing, and they're totally equal. 12 units is equal to 1 dozen. That gave me 13 dozen. When I subtracted the 12 units out, that left me with 5 units left. All right. Now, I cannot take out any more dozens. That's all that's left. I only have 5 left. All right. Now I'm going to go to my dozens. I now have 13 dozen. Okay, so I have 13 dozen. So I have more than 12. And 12 dozen make 1 gross. So I'm going to take one of those, I'm going to take 12 of those dozen over here to make a gross. Take 12 of these out, and I'm going to add 1 gross over here because 12 of them make a gross. So when I do that, I took out 12, I'm left 13 minus 12 leaves me with only 1 dozen left. Okay. Over here, when I took out the 12 dozen, I brought over 12, those 12 dozen made 1 gross, and now I'm going to add 3 gross. I just brought over 1 gross, and that's going to give me 4 gross. So my final answer is 4 gross, 1 dozen, and 5 units. So it's basically just the way that I explain this to my students all the time is the easiest way to think about this is if you have a big bowl of change, and if you have ever taken change, coin change, and you have separated it and tried to roll that change up and tried to take it to the bank to cash in. So you have to roll it up into so many rolls of quarters and so many rolls of dimes and so many rolls of pennies. So it's kind of the same thing. You know, it takes 50 pennies will make 1 roll of pennies. Okay. So, you know, if you can wrap your mind around that concept of taking away these units and turning it into something to a different denomination. You'll hear me say a lot of times in my math classes, 4 quarters and $1. They look very different, but they spend exactly the same. Okay, so all of these things are exactly the same. 12 units and 1 dozen, they may look different, but they're equal here. So 12 units is equal to 1 dozen. Okay, I hope that this helped. Hope it wasn't too confusing. Maybe it will help you as you work your way through section 4.3. As always, if you have any questions whatsoever, any problems, send me an email and I will be more than happy to help you with these problems. All right, good luck.